is Minho Kwak, an engineer from Samsung Foundry. I'm here to give you a brief introduction about Memory IPs that we provide. Hope you enjoy this short video and get some useful information about Memory IPs, which are a crucial part of modern IC design process. Here, the types of most memories are listed. We can mainly divide most memory into two groups with the volatility of its data. Dynamic RAM and static RAM are two kinds of volatile random access memories. For non-volatile memories, we have read-only memories including mask ROM, OTP, and flash, and non-volatile RAM including magnetic RAM. Samsung Foundry provides SRAM, mask ROM, OTP, flash, and MRAM with high performance and stability. Let's take a look at each of these memories and see what is special about Samsung Foundry. First, let's start with SRAM, which is one of the most basic and important memory IPs. We are providing SRAM in more advanced process without reducing the performance, but with lower power consumption. The size of SRAM bit cell becomes smaller and smaller as the process gets advanced. The variation of the transistors are increased, and this narrows process window of disturb margin and write margin. To get over this and improve write and disturb characteristics, read and write assist circuits are applied. We mainly use VDDC lowering for write assist and word line underdrive for read assist. However, the reduction of the bit cell read current and speed have been issued in this word line underdrive scheme. So we are applying temperature auto tracking assist, which is called TATA circuit, to adjust the word line level according to the temperature. Lowering power consumption is another important issue. But once supply voltage level is lowered, the intrinsic characteristic of the bit cell gets worse and causes a decrease of silicon yield. To overcome this, a dual power rail structure that separates the power of the bit cell and the peripheral is used. By lowering separate peripheral power, chip power consumption is reduced while maintaining the characteristics of the bit cell. In this case, word line underdrive affects the performance of SRAM due to the voltage difference between bit cell and peripheral power. So we are applying voltage auto tracking assist, which is called VATA circuit, to get over this issue. Our auto tracking assist schemes are presented in 2019 ISSCC, and the pictures here show the concept of these auto tracking assist circuits. Now, let's take a look at OTP. OTP, which stands for one-time programmable memory, is one of non-volatile memories which is able to program only one time. Due to its one-time programmable characteristic and that it can store data almost permanently, OTP is an IP which is complementary for both ROM and flash. Electrical fuse and anti-fuse are two types of OTP, and these are applied normally to store key codes for security, to access redundant SRAM memory replacement for dead bit cells, and so on. So, what's so special about Samsung Foundry OTP? First, our OTP has no additional mask step or layer in standard fabrication process, so it is effective in the view of process cost. Second, we have two types of OTP, which are E-fuse and anti-fuse. E-fuse is used for low-density OTP, and anti-fuse is used for high-density OTP. Therefore, customer can choose OTP according to their own preference. Third, we have 100% redundancy scheme for data reliability. So it is possible for customers to repair all bit cells without any restrictions. Fourth, automotive application has been set up. We solve programming disturbance issue at hot temperature with the help of disturbance compensator, which controls the cell bias condition. Our efficient functional safety scheme let us get the ISO 26262 assessment. Now, let's move on to the flash. Flash is a representative memory of non-volatile memories, with this characteristic as an EEPROM. Samsung Foundry uses ESF3 cell. High voltage is applied only to the cell being erased at the erase gate. Therefore, there is no erase stress to the cells which are not being erased. And there is no need to worry about over-erase because there is no need to calibrate after erase or program. Our flash satisfies automotive grade 1 conditions. Controlling the sensing condition is enabled with temperature auto tracking scheme. Boosting the gate voltage of the decoder to solve the leakage problem of high temperature is also applied, without any restriction in the speed. And the source line floating technique is applied as a solution to high temperature leakage. This allows the number of cells per bit line to be increased, resulting in the reduction of the size of flash IP. E-flash is also designed to have sufficient margin. On and off condition of the cell is stable since various voltage combinations are used for program and erase operations. In addition to its marginal strength and stableness, we were able to reduce the size of flash IP with BIOS coding separation and pump switching scheme. As a result, despite this small size, we provide flash that satisfies 500K cycle endurance and 25 years of retention. Finally, here we have an MRAM. With a wide variety of digital devices entering the market, demands for differentiated semiconductor solutions has been escalated. As a solution to such demands, Samsung Foundry has developed embedded MRAM, which stands for Magnetoresistive Random Access Memory. MRAM has advantages of both NAND flash and DRAM, which are not only non-volatile, but also has high speed in read operation. These strengths let MRAM grab attention as a next generation memory. Samsung Foundry has been developing MRAM since 2002, achieving world first 28 FDS MRAM mass production in 2019. This year, we started supporting 128 MB eMRAM compiler. Many embedded MRAM design technologies of Samsung Foundry were patented. Let's take a look at some of the technologies we have. The array scheme, which minimizes mismatches between reference line and bit line, was developed to increase the read margin. The difference between the two is very small, less than 1 femtofarad. SenseAmp with small offset is developed to distinguish the small difference between 0 and 1. In order to optimize this read power, it blocks the power consumed by itself after read sensing. We also have SG high voltage bitline switch technology that does not use additional voltage for small area. Adaptive bias circuit that changes bias according to the temperature for high endurance is used in this scheme. High current and many storage capacitors are required to generate the voltage for write operation. But we use small size write driver which does not require storage capacitors, resulting in faster write operation and smaller size. Samsung Foundry developed advanced embedded MRAM, demo and commercialized it as the first in the world. Embedded MRAM does not consume standby power for data storage and writes more than 1,000 times faster compared to flash. That's why embedded MRAM is expected to be the next generation memory, especially in applications that require small area, low power, and high speed. So this is what I have prepared for today for Memory IPs, to introduce you briefly about what we do and what we have as a strength in Samsung Foundry. Hope you enjoyed this video and you got some helpful information out of it. Thank you very much for watching, and I'll come back with more interesting topics. Thank you.